Hi, my name is Haoyu Lei. I'm a second-year PhD student in Dr. Xiaotao Yang's group. Now I'm working on the seismic imaging project of the North American mid-continent, mostly cover the North American Craton region. For the seismic imaging project, we mainly used seismic waves to study the interior structure of the Earth. Since the seismic waves carry information along the path that they propagate, so we can extract those information from the seismic waveforms and get the information about the structures. We mainly uses the ambient noise, the seismic ambient noise data. So the seismic ambient noise is different from the conventional earthquake waveforms because we don't need earthquakes to get the waveforms. This ambient noise is also called the Earth hum. So it is a continuous 24/7 waves that we can record, which were previously treated as noises. But people found in the past decades that we can actually retrieve useful information from the ambient noises, and we can use it as the same way as we did to the conventional earthquake waveforms to extract useful information. There are many reasons. It can be rains, winds, or the ocean's frictions with the bottom of the ocean's friction with the seashore or the sea bottom or the cars, trains. Yeah, it can be caused by everything. Or the tides. Yeah. We do not deploy seismometers. We download data from the ARIS data center or the other data centers. So mostly we use data from geophones. Those are all open source data. And you can always download them from the data center. For ambient noise, it usually needs several years of data. And the time we need to collect them depends on the speed we download the data from data center, which can vary from several weeks to several months.
Right. It could take you several months to download
Yeah,
data.
it took me 3 months to download my data. It depends on the sampling rate, like how dense your. It's not how dense, like because the waveforms are continuous. In order to store them in computer, we need to sample them. So the higher sampling rate you have, the larger the data, the more storage you need. So it really depends on the sampling rate. For my project, we hope to study how first of all, we want to study what is the structure of the North American mid-continent in the lithosphere. And we want to study the anisotropy. Basically, is you can understand it as the alignment or the orientation or direction of the structures underground. And secondly, we want to understand how these structures were formed over time. Since the North American Craton is one of the oldest continental cores on the planet Earth, and there must be a reason for this longevity, and we want to understand why it is like this. It will give us more understanding to the Earth itself, to the evolution of the continents.
What advice would you have for a high school student?
My advice is study more math and physics because math is really important in geophysics, especially when you do inversion. There are tons of mathematics, so you need to have a solid math background to understand everything. And it's also good for you to prepare for your future career because if you don't end up in in academia, you probably need some maybe data analytic skills to find a job.